Hey folks, I saw a cool Stack Overflow question come in recently and thought it'd be good to make a video. This touches upon a few aspects of writing a Rust smart contract on NEAR. So here we have it. The title is, Why Can't I Read This Hash Map in a NEAR Contract? At the top it says, I have a NEAR smart contract that keeps a hash map of veggie records. My most basic accessor, getVeggie, which looks up and returns one veggie record, is passing unit tests but fails in the actual deployed contract. It panics with veggie does not exist. I'm just kind of glancing at this. This isn't the entire contract, but this shows kind of what's going on, that there's going to be a veggies hash map apparently in here. If we scroll down a little bit, it looks like they are using NEAR CLI right here where it says NEAR call accountId, and this is an environment variable for their accountId and environment variable for the contract name. The method is getVeggie, which we see up here, and then you pass in the parameters here. So we have VID, and we notice that this is a very large number. So a couple of things are going to be useful here to point out. We can cover why NEAR collections are important and why it's not usually a good idea to use HashMap. And we can also talk about how to deal with passing large numbers as parameters, as we see we are trying to do here. Basic fact that HashMap is not something that we typically want to see here. I like to think of it in the example of basic attention token. I'm a huge fan of Brave and BAT, and that's an example of a ERC20 token on Ethereum that probably has many millions of keys and values associated with it. This person has 19 BAT, this person has 4 BAT, etc. When it comes to the blockchain, hash maps will actually go into this storage and load the entire data structure into memory. So think about that for something like basic attention token. You have millions and millions of rows, essentially, if you want to say it like that, key values. There'd be no way you could actually load that into the memory of smart contracts. So we have at NEAR collections. There are a few different ones, but these will actually have a different kind of data structure where you do not bring the entire thing into memory. It's much more specialized. Let's take a look at a simple Rust contract that I made after looking at this Stack Overflow question. I can close this for now. So typically the way that it's laid out is you have your cargo toml, which is similar to package.json, but for Rust. Inside of a source folder, you have your lib.rs. And a lot of our examples that we have at near.dev will just have all the code into one file, the lib.rs. You can definitely break it out, but it kind of makes it easier for simple examples. So let's just go through this little by little. Some of this is boilerplate. Some of this we can talk about a bit more. So at the top here, we're going to have some very basic imports. NEAR bindgen, we're going to need to have for these data structures that we want to have stored on chain. Env is important for things like logging and figuring out who is actually calling this, who is the signer, who is the predecessor of this particular transaction. Borscht is basically better than JSON serialization, and this is a huge improvement in terms of getting information to and from storage. So we will also be having a macro above some of our data structures for this. And then this is where we are doing something that's different than HashMap, like this original poster is talking about. We have specialized collections, as I mentioned. This one is called TreeMap. If you're a computer science person, that's an AVL tree. And actually, this was a bounty that a community member took up. So that is kind of cool. It's working great. And then lastly, this gets to kind of the second part of this Stack Overflow question with very large numbers, and there is a way to handle that, but I think we'll kind of wait a little bit for that. So essentially, we can skip over this a bit. This is smart contracts in the current state that they are don't really need to have much in terms of memory allocation. So we have this wealloc thing that can basically be copy pasted in essentially all smart contracts. We can kind of skip over that. We're talking about veggies here for some particular reason, which is cool. So I have a kind of optional thing just for fun that's a type UPC. And it's almost like an alias where I'm saying, like, if I use this type UPC, then you can consider it a U128. Notice already, this is a lowercase u, this is uppercase u. That's important. So typically when building smart contracts in Rust on NEAR, it's going to be like a struct that you are going to be having, and then you're going to have like an implementation definitions inside of this thing that you just created. So here we're saying like we are making this struct called produce, and it's just got one field that is called veggies_taste, and it is a tree map of a UPC to how tasty we find this thing. Obviously this is a kind of contrived example, but I think this will go a long way. I'm going to say this isn't also kind of boilerplate. This is just good practice when making smart contracts to make sure that the contract initialization happens. In the same vein, I won't spend too much time on this, but this is an initialization function inside of our implementation. That's the first definition inside here. This just makes sure that it hasn't already been initialized, and it will set up the data structure in here. Actually, this is an important part that I could mention. So when we have these specialized data structures like TreeMap, and you create a new one, this looks kind of weird. What the heck is like B, V, 2vec, all of that? So essentially, the way storage is going to work internally is there's going to be like keys inside of there, and there's going to be a prefix so that you don't mistake one key for another. In this particular case, we just have one field. We could have multiple fields. We could have a string here, a second tree map, a bunch of different items in here. And to differentiate those, you want to have a prefix. So this, if you look into the like literal storage, which is possible doing some kind of lower level RPC calls, you will see that this is actually prefixed with the letter V. So generally when using these data structures, it's, if you want to be super efficient and min-max this, then you can have this just be one letter, just to make sure that the storage is taking up as little space as possible. Okay, let's just keep going down through this. So we're going to have some super basic functions, 3 functions, I believe. Add veggie taste, get taste, and perish all. So here we go. We have add veggie taste, and this is going to be actually mutating state. So we need to have mute here. When we do get taste, you'll notice that there is no mute because this is simply just like viewing what's on there. And here we have our UPC is taking in as a param. This is capital U128, and the taste is going to be a string. So won't go too much into it here, except for if you're trying to add something that's already there, it'll say, sorry, we've already got this. Otherwise, it'll insert it. You notice the env panic is kind of like, throwing an error, and execution will stop, and it won't get to this point. Get taste is seeing if there is already that particular UPC in there, and then it will log a message using env log here, and it will actually return the stored taste in there as a string. So as we can see, this function is returning a string. There is kind of like an implied return in Rust. Same thing goes down here. And then perish will basically check to make sure that this contract that we have deployed to is the same as the predecessor account ID, which is basically saying the person who called this contract needs to have the key to this contract. So you can do this different ways, but this is essentially almost like a guard to make sure that not everyone can call this perish all function. Down here we have some tests. These are unit tests. There are a couple of different kinds of tests. I'll have a link here in the description about the various kinds of tests. So some argue that simulation tests are probably the most useful, but unit tests are especially useful when it comes to making sure that all of the business logic inside of your contract works. These do not work for like cross-contract calls, but they're a great way to like test that you're doing things right, essentially. So in normal Rust contract development, like if you follow the official Rust guide, great guide, it walks you through some simple examples, and you'll have an entry point, like a main function. We don't have that in blockchain, so tests like this, unit tests, are a great way to like quickly like run tests against your code. And in here, this is very much boilerplate above what you just see. I have one simple test, and this is all inside of a repo you can get. You will see that here we are creating a variable called cucumber UPC, and we are wrapping it. So we have a capital U128 of this very large number. And we are saying that this cucumber, it tastes so-so. So we have loaded the contract and we're calling this function saying that cucumbers taste so-so. And we test to make sure that it all worked accordingly, and it passes. You run this command with cargo tests no capture inside of this directory. That will do what you want. Okay, so we've covered a little bit of collections in terms of us using the TreeMap. Another thing to note is that there are a bunch of awesome other collections here. I have a link right there. It is a kind of different syntax if you want to load a bunch of them. It's very strange to just have one field on your struct, so it's likely that you'll use other ones. Here are some other options that you may consider along this, and again, like look at the different collections and the Rust crate documentation. So that was about the collections, and essentially I would probably go as far as to say never use hash maps. I can't think of a great time to do that. I suppose if you're having some kind of like 5-player game and it's always going to be each team has 5 players and you know it's capped out at that, then maybe it's not a big deal to load that into memory. But it's recommended to use the NEAR collections that we just talked about. So the second thing was this large number. And it looks like this particular poster answered already saying, caution, JavaScript is slightly truncates integers of more than 53 bits, and goes over how they ran into this. So that is true. And technically what this is that JSON serialization does not have that in the standard. I actually have another link that I will have in the description that is a quick demonstration of this in action. I won't go into that much detail except for to say this is a very simple REST contract defined of small underscore u. So this is as simple as it gets. We are taking in a regular lowercase u128 and we're just saying, hey, log what we got. I received this value. Super duper simple, right? So let's try calling that. This command that I'm going to be typing out is for NEAR CLI. So we're saying NEAR view on the contract debug.mic.testnet, call the method small u, and then we're passing in the parameter. Here we go, like a kind of a large timestamp here, right? So let's do this, and I received, okay, looks the same. No, it looks the same. Nope, it is not the same actually. This has 800. This one that we gave has 700. So this is a great example of how you cannot do this. You actually need to use the capital U128, which means that as you're passing it in, it needs to be as a string. So if we had this number right here surrounded in double quotes, then that can be seen as almost a string as it's getting passed from you into the blockchain. From there, you can convert it to an actual lowercase U128, if that makes sense. This does affect numbers that require more than 53 bits. So in that case too, there's a note that I have here. We're using U128. There is also U64 because this is more than 53. So those are two items that were kind of problematic with what's going on. We use the NEAR collections and realize that if you're passing in large numbers, you're going to want to basically treat them as strings. So given that knowledge, I think that this person can get unblocked here. How to actually build and deploy this. We've created a build.sh shell script. And it's going to do these two things. We're going to be running this command, cargo build, and then we're going to have this target wasm32 unknown. We'll have a link to what that is. And then we're saying, yeah, this is going to be a release. This will create a compiled wasmFile in a kind of deeply nested folder. And so typically we just say, hey, you know what? Just copy that and put it somewhere easier. Copy and put it right here. So that's what we're doing with this build. So let's just go ahead and do this. The way that you get a testnet account is you go to wallet.testnet.near.org, and I did that, and lucky me, stackoverflow.testnet was available. And there is a very interesting concept that I will not go into fully here. This would be another great video, but NEAR has sub accounts. And so what I'm going to do now is create a sub account for this particular Stack Overflow question. The Stack Overflow question in the URL is this. So I'm going to say, hey, NEAR, create an account called 643 blah, 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 .stackoverflow.testnet from the master account that I have, stackoverflow.testnet. So when I hit enter, it's going to look in a directory inside of my home directory called .near-credentials. It's going to find that indeed I have a private key to this stackoverflow.testnet. It's going to say, yeah, you are allowed to do that. So I hit enter. It has now created it. So now I control this account. And the key for stackoverflow.testnet has nothing to do with this account anymore. I cannot like delete this sub account using the key from the master account. So it's its own thing, but no one else can create this account for me. Run the build script, build.sh. It has already done it very quickly. And so here what is going to happen is we are going to deploy this file with a kind of a long command, near deploy to the account ID, the one we just created. Where's the wasmFile? The wasmFile is in this folder called res, veggieexample.wasm. And notice how we had these initialization pieces where we want to make sure that this contract is initialized right here. And then the init function right here. The init function I decided to call new. So we are saying, well, this is the first time we're deploying it, so we might as well, like in the same motion, let's call the init function called new. And in this particular case, we have no parameters, so we're just going to pass this empty object. It's talking to the rpc.testnet.near.org, and it's done. If you want to click on this, you can see that it is actually, this is our NEAR Explorer, and it will say it succeeded. This is kind of like Etherscan. So back here, okay, so we've deployed it. Now let's call this function adding a veggie taste. Near call, because we're mutating, because before it was near view sometimes, near call the same account, function name, add veggie taste, and then here we have two parameters. UPC, notice this big number is surrounded in double quotes. The taste is just all right. I'm saying cucumbers, just all right. And then the last one here is saying we are calling this from the account. Well, it's actually the same account in this particular case. Okay, it's done. Okay, let's try to get that. And since this is also just a view method, it's near view, get taste, and then you pass, there's only one parameter, that same UPC. And it says, this veggie is pretty just all right. This veggie is pretty just all right. So there we have it. Now, in this particular case, when we were adding the veggie taste, we were calling from the same account, but you know, near is permissionless. So this would be an example where we are calling a function from a different account. So we are trying to call the parish all function from Mike.testnet, which I also own. So let's just try that out and see what happens. Panicked, blah, 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 blah. This method must be a call by the implied contract owner. This is this error message right here where we were asserting that the current account ID is the predecessor account ID. I called it with Mike.testnet. That is not equal to the sub account that we just created. So it throws this error and it did not clear it. So we can actually make sure of that by saying, what is the taste? Yep, we still have that stored. Okay, but we could actually parish that by calling with the contract that we created. Just a quick test here. Okay. Now if we try to go and do the same thing, see how cucumbers taste, it says no veggie found because we have cleared it. Okay, great. So the other thing that may happen here is you are working on this, you're in a hackathon, or you're building a real dApp, a real project, and you say change this to have an exclamation point right here. You can go through and you would say, you know, build, and then you could say deploy it, that new change. So you run this. This time we did not have the initFunction flags. So you can do this. You can deploy to that same account and essentially overwrite it, and everything will be just fine. However, there is something that happens when you try to have the state change, then that will cause issues. So if I were to create another one of these, so if I were to have this, then I can't have it be V. I'm going to have it be Z because it has to be a different prefix, right? Let's try building it. Cool. Deploy it. Seems like everything's okay, but it's not. So if I try to near view this, then it's going to have a big error. And if I were to scroll up a bunch, and it would be kind of clunky to do on video, it's basically saying that there's a state mismatch. So you cannot be changing like the state variables like this. And in that case, what you would have to do is near delete, and we are going to be like deleting this and giving all the leftover near that's in that account to the original stackoverflow.testnet, and then you'd have to recreate it. And then let's say we deploy again. Now that it's basically completely reset, this time we will deploy with the initFunction and initArgs, since it has not been initialized yet in this essentially brand new account. Done deploying and initializing. Even though there's obviously nothing in here, we're going to call the same call near view. This is the same one that gave us that horrible error before. It's going to say no veggie found. So this is an important thing to realize, is if you're going to be having your contracts be very upgradable, that you can make changes like adding an exclamation mark inside of functions. You can actually add new methods here too, but you cannot be messing with how the state needs to be. Otherwise, you will have to delete and recreate it. So that is kind of an overkill on how you use NEAR and how you would solve this problem and how you would, you know, build, deploy, and make this whole thing work. Hopefully that was helpful. We're looking forward to making more videos like this and have these as resources to give to the community. So yeah, thank you for watching.